رحيم أعزائي طلبة وطالبات شهادة الثانوية العامة قسم رياضيات لغات، أهلا بكم. النهاردة إن شاء الله هناخد درس جديد في الاستاتيكا اسمه الكتلة السالبة. طبعا الكتلة السالبة ده درس جديد علينا، أول مرة السنة دي ينزل في ثالثة ثانوي. الكتلة السالبة ديت موجودة أصلا تبع درس اسمه سنتر اوف جرافيتي أو مركز الثقل. مركز الثقل احنا عارفين إن أي جسم له مركز ثقل، وما يكون جسم كبير بيتكون من جسيمات صغيرة، وكل جسيم صغير بيكون له مركز ثقل، وكل المراكز الجسيمات دي كلها بتتجمع في جسم واحد. بناخد المركز الثقل ديت بينه وبين مركز ثقل الأرض. طبعا بنظر إن هي صغيرة جدا لا ترى بالعين المجردة، ففي خط عمل مركز الثقل أي جسيم بالنسبة لمركز الأرض بيكون بيمر بنقطتين، والنقطتين دول مهمين جدا جدا. أما اليوم هناخد درس جديد اسمه الكتلة السالبة. الكتلة السالبة يعني عندي جسم أخدت منه جزء، فالجزء الباقي ده بسميه جوه الكتلة السالبة. Welcome my dear student in our math program for secondary 3. Today we are taking new lesson in static. What is the title? Is negative mass method. Negative mass method. This is following of center of gravity. If you have a raised body of mass m, look at this is closed curve represent a raised body of mass m. Center of gravity is represented by G, and we remove the part 1 of mass m1 and the center of gravity, or we cut part of this body, raised body, and its mass m1, center of gravity g1 from it. It's required to find the point g2. This point g2, which is the center of gravity of remaining part. Remember, dear student, we have raised body, its center G, center of gravity G. We cut part of the raised body, its center of gravity G1, and M1, its mass. The remaining body or left body or remainder body, its center of gravity G2. Then we know that its mass becomes m minus m1. Why? Because m is the mass of all bodies, or the mass of the body which its center of gravity G. If we cut or removing part of the raised body with mass m1 and g1, its center of gravity, then the remaining body is m2, its mass m minus m1. Let r1, r2, rg be the position vector of the point g1, g2, and g respectively with respect to the original point O. Then we know that position vector rg equals m1 r1 plus m minus m1 r2 vector over m. Remember, dear student, rg position vector of the body, rg equal to m1 r1 plus m1, m minus m1 is the mass of remaining body times r2 position vector over m. Then by using cross multiplication, we know that m times rg equals m1 r1 plus m minus m1 r2. Then mrg minus m1 r1 equals m minus m1 times R2. R2 equals, what is the R2 vector? Position vector of the remaining body. Excellent student. Using this equation, we find the value of position vector of R2 or position vector of renaming body equals mRg minus m1r1 vector over m1 minus m2. This is position vector. Remember, position vector of the remaining body is called R2 equals mRg minus mr1 vector over m1 minus m minus m1. And we can write this relation in terms of components in direction of the orthogonal coordinate axis OX vector and OY vector as follows by using x2 and y2. x2 equal mx minus m1 x1 over m minus m1. y2 equals my minus m1 y1 over also m1 minus m minus m1. This is Cartesian x2, y2. If we have R2 by using the previous rule, we calculate x2 by using mx minus m1 x1 over m minus m1. y2 equals my minus m1 y1 over m minus m1, where x and y is the center of gravity of the original body whose mass equals m. And the x1, y1 is the center of gravity of the removed part whose mass m1. This rule determines the position of G2, which gives the center of gravity of the remaining part as if that part is formed of the two bodies. The original body of the mass equals m. The removing body considered its mass negative is negative m1. Thus, this method is negative mass body. Now we are translate to important example. Dear student, for equal mass, each of 200 gram are placed as the vertices of square ABCD. Determine the center of gravity of the system, and if the mass placed at T is removed, determine the center of gravity of the remaining system by using the negative mass body. Solution. Dear student, we have square ABCD, 4/4, 4 mass, 200 each one, at A and B, C and D. Remember, square, its center of gravity, intersection of two diagonals at point E. AX represent x-axis, AY represent y-axis, two orthogonal axes. Let A be the center of the square ABCD. Center of square is intersection point of two diagonals. Remember, the square side length suppose equals L. Then AX and AY, two perpendicular direction represent x, y axis. A is the original point, 0, 0. We form the following table. Dear student, we have A, B, C, D, 4 vertices of square. What is the mass of A? 200, B 200, C 200, D 200. What is the position vector of point A? Yes, x 0, B as 0, this origin point, C as the distant L, also D distant L. What is the coordinate of Y? Respect to point A0, also B equals L, CL, but D equals 0. Then we have 4 mass 200 each one act on A, B, C, and D. What is the position of point A or mass 200, 0, 0, B 0L, C L, D L 0. Then by using the rules, we find xg by using 200 times L plus 200 times L over sum of mass 800 equals half L. By using the same method, we find yg equals 200 times L plus 200L over 800, then yg equal half L. What it deduce, dear student? The coordinate or the center of gravity of the system, half L coordinate. X equal half L, y equals half L at the point E. After removing the mass 200 gram exists at point C. Look at they are mass at E 800, where E its coordinate L over 2 and L over 2. Then a mass of C is negative 200, is removing body or remaining body by negative 200, where C its position L and L. Why? C is a distance from x-axis L and from y-axis L. Its coordinate is L and L. Then we form the table E and C. From E and C, E its mass 800 but C negative 200. Why? Because this remaining body at point C, negative 200 negative mass at point C. Then what is the point? What is the x coordinate of point E? L over 2, but C as L distant. Y coordinate at point E? L over 2, but C as L. By using the rule, then we find x g dash equals m1 times 800 times L over 2 minus 200 times L over 800 minus 200 equal third L. Also y g dash equals, by the same method, 800 times L over 2 minus 200 times L over 800 minus 200 equal third L. Then we find g dash equal third L, each coordinate x equal third L, each y equal third L. This respect to the point A. Now we are translate to important example. Dear student, if we have ABC is equilateral triangle of side length 30 centimeter. Remember, dear student, if we have triangle ABC equilateral triangle, what is the center of ABC? X and student. This is center of a triangle is point of medians. Intersection of medians is M as a distance from vertex 2 to 1 and 1 to 2 from the base. D is point of intersection of the its median. Why? Because D is center of gravity of equilateral triangle ABC. E is midpoint of BC. Mass of magnitude 20, 40, 30, 60, 50 gram are fixed at a point A, B, C, D respectively. Remember, we have 5 mass and 5 points. 20 at A, 40 at B, 30 at C, 60 at D, 50 at E respectively. Identify the center of gravity of the system. Dear student, then where does the center of gravity of remaining system lie with respect to the vertex C if the mass existed at B is removed. Solution. Look at, dear student, let Cx, Cy be two perpendicular direction and C is original point as the figure. Look at, we have ABC is an equilateral triangle, each side length 30 centimeter, D point center of the median. Remember, center of the median divided the median as ratio 2 to 1 from the vertex, 1 to 2 from the base. We have Cx, Cy represent x-axis, y-axis. We have math 20, 40, 30, and 60 act at A, B, C, and D. From the figure we get AE equals what? 30 sine 60. Why? Because look at AEC. ACE, let's measure angle 60 degrees. AE over AC equals sine 60. Sine 60 equal AE over 30 by using AE equals 15 root 3 centimeter. Why? Because sine 60 root 3 over 2 times 30 equal 15 root 3. This length of AE. After that, we know that DE is third AE. Why? Because D is point of intersection of medians or point of consonance. Point of consonance, D divided each median as ratio 2 to 1 from the vertex, 1 to 2 from the base. Then DE equal third times 15 root 3 equal 5 root 3. After that, we form the following table. We have 5 vertices. What is the 5 vertices? A, B, C, D, E. What is the mass? The mass at point A, 20, at B, 40, at point C, 30, at point D, 60, at point E equals 50. What is the X? X at point A equals 15, at point B, 30, at point C, 0, at point D, 15, at point E, 15. What is the coordinate of Y? 15 root 3, point A, 0 point B, C point 0, D 5 root 3, but E point 0. Then by using the rule, we find xg by using 20 times 15 plus 40 times 30 plus 6 times 15 plus 15 times 50 times 15 over sum of the mass, 20 plus 40 plus 30 plus 60 plus 50. Answer is 15 and 3/4. After that, we find yj by the same method. We find 20 times 15 root 3 plus 60 times 5 root 3, and answer is 3 root 3. Then the center of gravity of the system, G equal 15 and 3/4, 3 root 3. Its coordinate, the center of gravity of the system represents a point G, represent its coordinate 15 and 3/4, 3 root 3. Look at again, if we have ABC is equilateral triangle, look at after removing the mass 40 gram, look at the point B. The mass is negative 40. Why? Because this is the mass of the body which removing from the whole body. After removing the mass 40 gram existed at point B. Then we form point G and point B and find the mass of each one at G 200 but B equals negative 40. Then we find the value of X. Point G is 15 and 3/4 but point B is 30. Y at G equals 3 root 3 at B equals 0. By using the rule, we find X G dash equals 200 times 15 and 3/4 minus 40 times 30 over sum 200 minus 50. Answer is 12 and 3 over 16. After that, we find y g dash by using the same method. 200 times 3 root 3 over 160 equal 15 root 3 over 4. Then the center of gravity of the system after removing the mass 40 gram is at point B is g dash equal its coordinate 12 and 3 over 16, 15 root 3 over 4. Now we are translate to another example. Find lamina of uniform density in the form of a rectangle ABCD in which AB equals 8 cm, AD 12 cm. Remember, we have fine lamina of uniform density. What is the meaning of fine lamina of uniform density? Its center is intersection as a rectangle. As a rectangle, its center of gravity intersection point of its diagonal. If we have ABCD as a rectangle, diagonal ACBD center of gravity lie on intersection point of two diagonal ACBD. Remember, AB equals 8 cm, AD equals 12 cm. The square BNTE of side length 4 cm is removing. Remember, we have a square BNTE part of rectangle. We have a rectangle ABCD. We cut from it lamina as shaped rectangle ABCD. We cut from it square BNTE of the side length 4 cm is removing, and if the remaining part is suspended freely from the point Z belongs to AD line segment where is at 1.6. Find in equilibrium position the measure of angle of inclination of DA to the vertical solution. Look at ABCD is lamina as rectangle. We cut square BETN negative M, it's math. Look at area when we divide by area of a square BNTE over find the ratio between area of a square and the area of a rectangle. What you deduce? Area of square BNTE over area of rectangle ABCD equals what? Equals 4 times 4 over 12 times 8. What is the area? 1 over 6. Remember, 1 over 6. What do you mean? The area between square and rectangle are proportional with two mass. Why? Because the mass equal 1 over 6 of the large mass of lamina as shaped square. Then the area of the square and the area of square of rectangle are proportion with its mass. Then the mass of rectangle equal 6m at G1 equals 6 for its coordinate. The mass of the removed square equal negative m at G2 equals 10 and 2 its coordinate. Then xg by using the rule we find xg 6m times 6 negative m times 10 over 6m minus m equal 5.2. Then yg equals what? By using the same method 6m times 4 minus m times 2 over 6m minus m equals 4.4. Then the center of gravity of the system G equals 5.2, 4.4. Look at again the vertical line ZG to be vertical line and draw GF perpendicular DA. Remember, dear student, look at the figure or the graph we draw ZG to be vertical line and draw GF perpendicular to DA. What did you use? In triangle ZFG, we have tan theta equals opposite over adjacent. What is opposite? FG. What is adjacent? ZF. Then GF equals what? 8 minus 4.4 equals what? 3.6 centimeter. Then tan theta, by using ZF equal 5.2, also minus 1.6, 3.6 centimeter. What did you use? X and 7. Tan theta equals 1. Why? Because tan theta 3.6 over 3.6 equals 1. What is the measure of theta? 45 degrees. Then inclination by 45 degrees. Now we are translate to another solution to this example. Look at, we have CX axis, UI axis, pi. If the mass of the removed square is m, then it can replace pi for equal mass. Why? Because 4 equal mass in 4 verses. Each mass negative m over 4, quarter, negative quarter m, placed at B, E, B, N, T, and E. The mass of square is m. Each of mass negative m over 4 or negative quarter m placed on the 4 vertices of square B, N, T, E. Then let's see x, y by two perpendicular direction shown in the figure. We know that form the table for mass and their coordinates. The table N, B, E, T, R, mass is negative m over 4, negative m over 4, negative m over 4, but R equals 6, x equals 12, 12, 8, 8, 6, y equals coordinate 4, 0, 0, 4, 4, and by using the rule we find the value of xg equal 5.2. Also by using yg also equals 4.4. Dear student, this lesson is very important lesson. Why? Because it's part of center of gravity. Dear student, I am very happy to spend such time with you. Remember, math symbol